This is video 3.2.1, and the goal of this video is to understand how to read, evaluate, and change to a logarithm. So some of you may have remembered logarithms from last year, but just to review, logarithms, one of the key uses of logarithms in the real world, and these are quite common to be used. We describe things on a Richter scale when we're talking about earthquakes and the intensity of an earthquake. And because of the fact that for each increase in 1 unit on the Richter scale, there's a tenfold increase in the intensity of an earthquake. So when they say that it's 7.1 on the Richter scale, that means it's really 10 to the 7th more intense than a unit of 0. Okay? So when we look at some application problems, you'll see that pop up. But that's one of the biggest uses. The Richter scale is a logarithm, and it is using logs to describe intensity of an earthquake. So first of all, the definition of a logarithm. A logarithm is really the inverse operation of an exponential function. So I know this is a little hard to read, but this says y equals log base b of x. And that's equivalent to saying b to the y equals x. Okay? So a couple of things to note here. B is what we call the base. It's the base of the exponent, it's the base of the log. Okay? Y is the exponent. Y is the exponent. And x is the value. It's kind of the value of the base at that exponent. So it's two ways to express the same thing, but what's really important is that you just learn how to read logs and listen carefully to how I read them and try to train yourself to read them in a similar fashion. Because if you can read them this way, then you'll have a better opportunity to memorize and understand how to operate with logarithms. So let's take a look at some examples of what this means for us and what we're going to be calculating. So we're going to start with changing the following from a log form to an exponential form, or vice versa. So if I see the statement 2 equals log base 5 of x, so 5 is my base. This says that 5 to the second power equals x. Okay, so it's kind of a big cycle. Now if I'm going to go backwards and I'm going to do it with the 12 to the second power equals x, 12 is my base, so it's going to be log base 12 of x equals 2. So again, I'm going to do log base 12 of x equals 2. So the result, remember, is your exponent. So this value here is our exponent, just like the value here was the exponent. And we do it again with the base of b to the third equals 64. So b to the third equals 64. So knowing that this is your base of your exponent is going to be one of the key things for you. So this is the base of the exponent, so I'm going to do log base b of 8 equals 3. Okay? And then remembering that this is the exponent every single time. Okay? So some key characteristics, some key things to remember. So the base of the log is the base of the exponent. So that's the key here, and that's why we're using b more often than not. Let's take a look at some other examples where we're going to be asked to evaluate. It's good to think back into exponential form since we're faster with exponential form. This statement right here says that 2 is the base to some power equals 16. Because when I'm asked to evaluate, I'm really trying to find the value. What is this equal in number terms? So this is equivalent. These are equivalent statements. 2 to some power equals 16. Well, hopefully you can think through that and guess and check and realize that 2 to the fourth power equals 16. So the answer here is 4, because 2 to the fourth power equals 16. The next one. So now we have base 3. So log of base 3 of 9. Okay? This is asking what power of 3 will give me 9. Okay, what power of 3 will give you 9? So 3 to some power gives me 9. So hopefully we know that that is 2. Again, this next one, log base 25 of 5. This is saying what power of 25 will give me 5. What power of 25 will give me 5? So 25 to what power equals 5? Wow, this number shrunk. So hopefully remembering when it makes things shrink, that there's going to be a special value in the exponent. And it's not going to be a regular number. Because 25 to the first power is 25. And second thing, hopefully remembering, is that 5 squared is 25. And therefore 25 to the 1. (25 to the 1/2 power, because we simply times both sides to the 1/2 power. So we take both sides to the 1/2 power and we get 25 to the 1/2 equals 5. So we'll be reviewing fractional exponents in this unit as well. So evaluating is looking for a value. Changing things from logarithms to exponents is a very important thing to be able to do. So let's take a look at your checkpoints for today. Remember, there's always a multiple choice question that you'll have to explain and a free response question. So do your best to try these problems and bring in your questions into class tomorrow.